Alrighty, guys, we're going to be looking at the objectives 3 and 4 of section 2, simplifying those radical roots. Today, we're going to be throwing in some variables. So it's not too difficult. What you're going to do is the index will divide the exponents of the variables. If it doesn't go into it evenly, the remainder is going to stay inside of the radical. So there's your keys to doing this. So let's look at a few examples of this. They go pretty quick. So remember, a square root has an understood index of 2. So if we take the exponent on the inside and divide it by the index, 5 divided by 2, how many times does 2 go into 5? It would go into it twice with a remainder of 1. So I'll write that down. The times it goes into it is going to represent the exponent on the outside. So it's going to be x squared on the outside. The remainder is going to represent the exponent of the variable on the inside, but we wouldn't put the understood 1. So the square root of x to the 5th is x squared square roots of x. On number 2, we add a coefficient, so we're just going to do it piece by piece. So I would separate it into the square root of 8 and the square root of y squared. And this is just like we did yesterday. What's the perfect square that divides 8? It would be 4 times 2. The square root of 4 is 2, so we get 2 square roots of 2. That part's simplified. And then the square root of y squared, that one's pretty obvious, but if you want to do the index, 2, how many times does 2 go into 2? It goes into it once with a remainder of 0, right? So that would be y to the first on the outside, and then there's nothing on the inside of the radical. And then we just got to put our answer back together. The things on the outside of the square root symbol will go together, so that would be the 2 and the y. And then the square root of 2 would tag along on the end. So we get 2y square roots of 2. Number 3, again, you want to do it piece by piece. This time they're vertical pieces, so we have the square root of 45 on top and the square root of x to the 6th on bottom. So looking at that numerator, what perfect square divides 45? Well, 45 is 9 times 5. And the square root of 9 is 3, and then I would have the square root of 5. And then on bottom, put the index. How many times does 2 go into 6? It goes into it 3 times with a remainder of 0. So again, that represents the variable's exponent on the outside. The remainder is the variable's exponent on the inside of the radical, but there isn't one, so that would be just x cubed. Remember, the index divides the exponent. 6 divided by 2 is 3. Number 4, again, we've got lots of pieces. So I'm going to do the top and do the 3 pieces. I'd have the square root of 5 and the square root of p to the 3rd. On bottom, the square root of 9. Okay, I'm looking at the square root of 5. There's nothing that simplifies that, so I'm just going to go to that radical. Understood index of 2. How many times does 2 go into 3? It goes into it once with a remainder of 1. So that would be the square root of 5 would tag along. Once would represent the exponent of the p on the outside, so p to the 1st. And then the remainder is the p on the inside, also p to the 1st. On bottom, the square root of 9 is just plain old 3. Now I need to fix up this, make it look better. I want my things on the outside of the radical together, and then the things on the inside of the radical together. So it'd be p on the outside, 5p on the inside, all over 3. Number 5, I think, is a typo. Cube root of 7 doesn't simplify. I don't know why I put that. Sorry. Let's look at 6. Separate it into the pieces. So I've got the square root of 12 and the square root of a to the 4th. What perfect square divides 12? That would be 4 times 3. So square root of 4 times square root of 3. So that's 2 square roots of 3. This one, how many times does 2 go into 4? It goes into it twice with a remainder of 0. So that would just be a to the 2nd. Nothing on the inside because there's no remainder. Put the pieces together. 2a squared square roots of 3. Number 7, got the square root of 98 over the square root of z to the 8th. What perfect square divides 98? That would be 49 times 2. Square root of 49 is 7. Square root of 2. And then on bottom, how many times does 2 go into 8? 4, remainder 0. So then that would be z to the fourth with nothing left into it. So that's as far as that one would go. Okay, and if you want to pause the video and try 8 on your own, that would be good. Otherwise, I'll walk you through it. Okay, again, separate into the pieces. The square root of 11, the square root of y to the 9th, and the square root of 49. The square root of 11 doesn't simplify, so I'll just rewrite that. And then y to the 9th. So we're doing the square root of y to the 9th. So how many times does 2 go into 9? It goes into it 4 times with a remainder of 1. So that would be y to the 4th on the outside, and then y to the 1st on the inside, but we don't need to the 1st. On bottom, square root of 49 we all know is 7. Okay, so this then just give us a final answer of y to the 4th on the outside. On the inside we have the 11 and the y, and then on bottom we've got the 7. Okay. Objective 4, it's just saying that we can do the product rule and quotient rule for any exponent. It doesn't have to just be square roots. So we're going to be looking for cube roots and fourth roots. So on this one, we're going to have to think about perfect cubes and perfect fourths. And our list was extensive yesterday with cubes and fourths and maybe even fifths. It's going to be even less. So 1 cubed is 1, so there's our first perfect cube. 8 is our next one. 27, 64, 125, and that's probably all you need to really know. If you know up to the 5 to the third is 125, you'll be fine. For fourths, we'll write down a few of those. Again, you don't need to know, you need to know even fewer probably than the cubes. 1 to the 4th, still 1. 2 to the 4th, 16 is the next one. 81. That's probably good enough. If you know 3 to the 4th is 81, that'll probably get you through all of the problems. And then to the fifths, something to the fifths, we do have a couple of those. We'll write down some of those. 1 to the 5th, of course. 1 is the first perfect fifth. 2 to the 5th, the next perfect fifth is 32, and honestly, that's probably it. If you do want to know 3 to the 5th, it's 243. So if you know the first 5 perfect cubes, and then the first 3 perfect fourths, and then maybe the first 3 perfect fifths, you're going to be able to conquer these problems pretty quickly. Okay, so we're going to do, these are just like problems from yesterday, except for instead of looking for perfect squares that divide it, we're going to be looking for perfect cubes if the index is 3, or perfect fourths if the index is 4, and so on and so forth. Okay, so let's look at our first problem, the cube root of 54. So which of these perfect cubes divides 54? 27 does. So we can say the cube root of 54 is the same as 27 times 2, the cube root of 27 times the cube root of 2. And what's the cube root of 27? It's of course 3. So we get 3, and then the cube root of 2 tags along. Number 2 here, the cube root of 18. 18 is not divisible by, and remember you don't really ever divide by 1 because that wouldn't change anything. 18 is not divisible by 8. And it's not, and 27 is already bigger than it. So this one is actually already simplified. Number 3, quotient, separate the pieces. Cube root of 7 on top, cube root of 8 on bottom. Cube root of 7 isn't divisible by any of our perfect cubes, so it's going to stay that. On bottom, what is the cube root of 8? It is a perfect cube itself, so the cube root of 8 is 2. So you have the cube root of 7 over 2. Number 4, again, separated into the 2 pieces. Cube root of 40 on top, cube root of 27 on bottom. What perfect cube divides 40? 8 does. So it's going to be the cube root of 8 times the cube root of 5, because 8 times 5 is 40. And then the cube root of 27, 27 is a perfect cube, it's 3. What's the cube root of 8? 2. And then the cube root of 5 does not simplify, so it tags along all over 3. If you want to pause and try 5 through 8, that'd be good. Okay, let's see how you did. This one's divisible by 8, so 8 times 3 is 24. Cube root of 8 is 2, so we have 2 cube roots of 3. Number 6, 38 is not divisible by 8 or 27. This one, again, is already simplified. Number 7, cube root of 5 on top doesn't simplify. Cube root of 27 is 3. So you have cube root of 5 over 3. And then number 8, cube root of 15 on top. On bottom, cube root of 64. What perfect cube? Oh, 64 is a perfect cube, right? 4 to the third is 64. There's no perfect cube that divides 15, so that one's going to stay. Cube root of 15. On bottom, get 4. Okay, number 9. Oh, how about we do this? You can comment on the video on how many you got right out of those 4. Right? YouTube lingo, right? Okay, let's look at number 9. This time we're looking at 4th roots. So our list is much less. Which of these, other than 1, you're never going to really use 1. Which of those, because that doesn't change anything, which of those divides 243? Well, 81 does, because I know that 3 to the 5th is 243. That is kind of helpful for this. So 243 is the same as 81 times 3. So the 4th root of 81 times the 4th root of 3. And the 4th root of 81 is 3. So we get 3 4th roots of 3. Number 10, separated into the 2 pieces, the 4th root of 3 over the 4th root of 16. On top, 3 is too small. It's going to stay that way. 4th root of 3. On bottom, 16 is a perfect 4th. It is 2. Okay, 11, we've got a 5th root, first 5th root one. So we're looking at our pink list here. Again, you're never going to use 1. 32 divides 64 clearly, so you're going to say that's 32 times 2. And the 5th root of 32 is, of course, 2. And then the 5th root of 2 just gets rewritten. If you want to try 12, 13, and 14 on your own, that would be awesome. They look like 9, 10, and 11. Okay, we're back to the 4th roots. This is 16 times 2. So that would be 2 4th roots of 2. On number 13, we'd have the 4th root of 5 on top, the 4th root of 81 on bottom, and 81 itself is a perfect 4th. It is 3. So we get a final answer of the 4th root of 5 over 3. And then number 14, the 5th root of 96 is 32 times 3. And the 5th root of 32 is 2. And the 5th root of 3 tags along. So it's really just a division problem. Can you divide and then apply the radical? Let me know if you need any help. Good luck on the My Math Lab assignment. Talk to you soon.